The next introduction that I get to give is for our keynote speaker today. And you don't have her bio, but I do. So I get to tell you some of the very exciting things that she's involved with. So Dr. Nancy Currie-Gregg has a PhD in industrial engineering from the University of Houston. She's a retired United States Army colonel and a Master Army aviator, logging over 4,000 flying hours. She was selected as an astronaut at NASA, served as a mission specialist on 4 space shuttle missions, and accrued 1,000 hours in space. Principal engineer in the NASA Engineering and Safety Center, that was following the Columbia tragedy in 2003. Currently, she's a professor of the engineering practice at Texas A&M and an adjunct professor of our department, that's an industrial and systems engineering department at NC State. There's some important awards and honors that Dr. Currie has received. For example, she's received the U.S. Government Presidential Rank Award of Meritorious Senior Professional in 2015. That's given by the President of the United States. She's received NASA's highest award, the Distinguished Service Medal, in 2003. And she's had other awards, including the NASA Outstanding Leadership Medal, the NASA Exceptional Service Medal 2 times, the Army Aviation Association of America Hall of Fame. Her research interests are in human-robot interaction, spacecraft occupant protection, systems safety engineering, and human systems integration. She teaches courses in human factors engineering and ergonomics, systems engineering, and systems safety engineering and risk management at Texas A&M. We are very proud that Dr. Nancy Currie-Gregg is able to join us today and that she's going to talk to you a little bit. And so please join me in welcoming her to the stand.
Pleasure to be back in Raleigh. I really consider this one of my homes. I've had a long standing tradition of working with the department over about a 11-year period, I guess. I have many friends here, spent a year as a visiting faculty member here in 2012. And so it's always a pleasure to come back here and address you. To the folks who received the Distinguished Alumni Award, my heartiest congratulations. And I think for the students who are in attendance, what you've heard from all of those distinguished alumni is that this department provided the foundation on which they have built the tremendous careers that we have heard about today. And so you have that same opportunity, that same excellent faculty, same excellent education that those folks did, and you can model your careers in the same manner. What I'd like to do just briefly today is talk about realizing bold visions. I had a very bold vision as a little girl, and that was to be a military aviator. And I was born in 1958. No one ever told me that was not a possibility. And this was prior to the internet, so I couldn't Google it. So I did not realize that there were not female military aviators. In 1975, that became a reality, and I graduated from high school in 1977. The first group of female astronauts was selected in 1978. I graduated from college in 1980. I remember in my late 20s thinking that all those changes were made a long time ago, and as I've gotten older, I realized that those doors were open just in the nick of time. And so I'm very thankful for those trailblazers like Dr. Sally Ride that I had the opportunity to get to know, who opened those doors. Because when I came along, they were wide open. The next bold dream that I had was once I was a military aviator and had a master's degree, I started looking at the astronaut program. And I will tell you, there were people that told me, you're chasing a pipe dream. You know, the selection rate for astronauts is 0.08 perhaps, maybe even less. You know, thousands of people apply for the program, and just a handful are selected every few years. But it was a vision that I had, and I always viewed my career as this ladder. And And no matter where I stopped, I knew that I would have a successful and a very enriching career because I loved what I was doing and I had a great passion for it. So I would have never been a military aviator had I not thought that, well, perhaps I'll do that for the rest of my life, and I would have had a very enriching and rewarding career if that had happened. So in 1986, I was an instructor pilot at Fort Rucker, Alabama, and I applied for the program, and I had actually applied in the fall of 1985 and was told I was going to get an interview. I was turning in my aircraft keys, and people said, did you hear what happened this morning? And I turned around and on the news was the Challenger explosion. Needless to say, they canceled astronaut interviews that year. But the very next year, in 1987, I received a call in January of 1987, and they said, we would like to interview you to be an astronaut. The interview process is a week long. It's almost all medical procedures. By the time that week is over, you either know that you will live forever or die tomorrow, because they look at you in every conceivable way, through every conceivable orifice they possibly can possess. And so it's almost entirely medical. And I said, this is the most wonderful news I've I just had a child. And they said, when? And I said, Friday. So, and they said, well, we'll do you a favor, we'll put you in the last group. So I went down and I interviewed, and I thought that would be my claim to fame. I thought my claim to fame was, well, once I actually got the interview to become an astronaut. So I was very relaxed, just had the time of my life. So there was no one more surprised than I when I got a call that said you weren't selected, because I figured that was a call I would get, but it was quickly followed with, we'd like you to come work here. So I thought that was a standard rejection call until just a few minutes later, I got a call from the senior Army astronaut, and he said, no, they want you to come work here. And at the time, I had orders to go to test pilot school, and I would have been the first Army officer, female, to go to naval test pilot school. So I called the Department of the Army, and I talked to my assignments officer. And for those of you that have been in the military, you know it's sort of a black hole up in the Pentagon. And I told him I was going to turn down test pilot school. And he said, and I quote, you are committing professional suicide. And I said, I realize that, but I have to pursue this dream that I have. And so I packed up my newborn and all my belongings, and I went to Houston. And in 1990, the next time they had an interview, I was selected. And again, there was no one more shocked than I. I literally fell out of my chair, at which point my office mates realized the call I was getting, and they started running up and down the hall screaming, she got picked, she got picked. And on the other end of the phone, they're telling me, by the way, you can't tell anybody for 24 hours. Oops. So it's all about realizing bold dreams. Now, in the astronaut office, we have a saying, all missions are good missions, but some are just a little better than others. And if you had told me as an astronaut that I would be a part of this bold vision to construct the International Space Station, I would have never believed it, even as a young astronaut. The story starts back in 1988. So in November 1988, the first element, the first Russian element, was launched on a Russian proton rocket out of Baikonur. Made quite a few visits over to Kazakhstan. When you get to the Baikonur Cosmodrome, all you see is rockets and camels. It's kind of a very interesting place. But they do have a house that Yuri Gagarin stayed in before he launched into space for the first time, so there's a lot of history there. So we were over at my commander's house about 2 o'clock in the morning in Houston, watching this on the news, hoping that this launch was successful. We were originally supposed to launch in early 1997, and there were repeated delays, as many cases there are with very complex projects. The first Russian element is called the functional cargo block, and its nickname was Zarya. Zarya is a Russian word for sun rockets. It was the dawning of this new age of human space exploration. So just a few weeks later, December 4th, 1998, it was our turn. You walk down that same ramp that Neil Armstrong walked down when he started out his day on his mission to the moon. And just, you were so well trained, and all you're thinking about is your job. And but you also are enormously cognizant of the history and those that have preceded you. We launched at night, and it would be interesting to note that we trained for this mission for 3 years. And it was at breakfast that morning, which is just kind of a show because nobody actually eats breakfast because people are worried about not feeling too well once you get to space. And so it was at breakfast that morning that one of the crew members remarked, "Hey, has anybody else done a night launch before?" We compared notes, and he was the only one that had. And he said, "Well, by the way, on a night launch, it's going to look like we're flying in a fireball, so don't be concerned." I thought, wow, I thought we would have talked about that like 2 years ago. And in fact, it looked like we were flying in a fireball, and we had a communications issue where we couldn't talk to the ground. So I thanked him more than once after we got back for letting me know about that. So this is just a short clip of our actual launch. So that's my little head in the middle. I was a flight engineer on all 4 of my missions and the robotic arm operator. That's the crew access arm as it's moving back. T-minus 6 seconds, the 3 space shuttle main engines come up to power. Each one produces 375,000 pounds of horsepower. And you're going to see something here called the twang. The vehicle actually rocks forward. You can visibly see that rock. And then at T-minus 0, hopefully when you're straight, the solid rocket booster is light. Each one produces 3.1 million pounds of thrust. That's launch. And so you can see it's a pretty dynamic event, is the way we would describe it. And in cruder terms, it's shake, rattle, and roll on the first stage. When you are on the solid rocket boosters, it's shake, rattle, and roll. It's actually hard to keep track of all the systems and instrumentation because your head's moving around so much. We rolled the solid rocket boosters for the first 2.5 minutes of flight, at which point explosive charges go off and they're jettisoned, and you'll see what that explosive charge looks like from the inside. You can't hear too much. You hear a loud kind of metallic clank, but you definitely see the explosion going off. And then for the next 6 minutes, it's just a smooth, gradual acceleration. At the end of the ascent profile, you're going 3G, so acceleration vector is right through your chest. And then when you get to 0G, you see, well, something came off. It's Velcro tether there, goes floating by. And all the folks that have flown with me over the years know when I get to orbit, I release my seatbelt, start floating, and I get a huge smile that doesn't depart until we come back home. That's the solid rocket there. That's the external tank that the cryogenic fuel is stored in. That's jettisoned, and then it burns up in the atmosphere. So this was the first flight that I told my late husband, who was also a military aviator. I told him, you know what? I'm really not worried about launch. I'm worried about what happens when we get there. Because this was a multinational project. The Russians, the Americans, Canadians, Europeans, Japanese. And so there were literally tens of thousands of engineers across all these countries that were waiting on us to lay the cornerstone of the International Space Station. If we were not successful, there would not be an International Space Station. That's a lot of responsibility, literally in your hands as a robotic arm operator. So the lesson for being an astronaut is always be worried about launch. We went out on December 3rd, and we had an anomaly on the pad that turned into sort of a last-minute scrub. And in fact, at one point they were talking about launching us, and we were going to be out of our launch window. And I told the commander, "Hey, boss, we're going to be out the window." Wondering why all those people on the ground didn't realize I hadn't been in my seat. My hand calculation was doing that. And so we ended up not going that evening, and the boss said, when you get out of the vehicle, remember the camera's going to be on you, so don't anybody look disappointed. I said, trust me, I'm not disappointed at all that we didn't go today. And I called my husband and I said, okay, I think we're really ready to go tonight, because now I'm scared to death of launch again. So it's a good thing. So this is the U.S. node. It was carried up in the payload bay. The interesting thing about this is the payload bay is 15 feet across. That vehicle took up almost every conceivable space in the payload bay, to the point where we went down to the Kennedy Space Center And we were talking with the engineers, and we were looking at the vehicle, and they said, who's the robotic arm operator on this flight? And everybody pointed at me. And they said, it took us 3 days to get this thing in the payload bay. Are you sure you can get it out? I said, well, I certainly hope so, because we really need that piece. So we took out the US node, put it on the docking adapter, and then we did a rendezvous, and that's the view in the upper right that we saw, the functional cargo block on orbit waiting for us. Rendezvous are really interesting. You're basically flying Mach 25 formation on another vehicle. And this period ended, which is affectionately known by all the crew members as the longest 15 minutes of our entire life. What happened was, the requirement was to do the grapple over a Russian ground site. They do use satellite communications, but their primary means is still over ground sites. And we arrived a little bit early, and so we had to station keep just a few feet away for 15 minutes. So we're occasionally firing a thruster on the vehicle. You're trying to zero out the relative rates between the two vehicles to make sure there's no relative rates. And just before it was time for me to start flying the arm, one of the jets fired. And it just looked like, the spacecraft, the relative rates took off. And it was a little bit of excitement. And finally the boss says, okay, that's as good as I can get it, over to you. And I'll tell you, when I went back to the robotic arm operator station, I had been doing the rendezvous in the front of the vehicle. When I went back, I was nervous. And as soon as I put my hands on those controls, all the training kicked in, and it was just, I felt like, and I told my trainers in Houston and all the engineers, I felt like behind my hands on the controls were 10,000 people helping me do this, and I wasn't worried at all. So once we got it captured successfully, now we had to put it in place. And it had to be put in place with a pressurized docking adapter at the top of the node, so we couldn't see that interface. The tolerance requirements were plus or minus 2 inches and 2 degrees. This was a Russian docking adapter that was adapted for this mission and required a certain rate of closure. And so we literally positioned in free space and then fired the jets on the shuttle to literally provide enough thrust for this system to operate properly. One time in training we asked, so if we're not aligned by plus or minus 2 inches and 2 degrees, what can happen? And they said, well, the worst case scenario is that there's too much force hard on the arm rips off the shuttle and takes the FGB with it. And they said, well, that's just the worst case scenario. So it's things like that keep you up at night when you're training for a mission. You notice there are black and white dots all over both of those segments. That was a photogrammetric system that we used for alignment. It had a series of arrays of 4 or 5 targets on one system, 4 or 5 targets on another, and the differential position gave you position and attitude information. However, black and white targets do not work very well in space with cameras because the lighting is changing constantly. It's the most dynamic lighting conditions I have ever witnessed in my entire life. You orbit the Earth every 90 minutes, so you're experiencing a sunrise and sunset, every 90 minutes. And so the lighting, it's the harshest glare I've ever seen, the darkest of dark, and the lighting is constantly changing. So when a shadow goes over a black on white target, the target drops lock. And so that system was not very useful at all. But that did work, and so then we were off for 3 days of spacewalk activities to make all the connections. Now remember, one of these vehicles was manufactured in Russia, launched from Kazakhstan. The other one was built in Huntsville, Alabama, and launched from the Kennedy Space Center. They had never been physically connected before we took them out 230 miles above the Earth. And also, every time we did a simulation, there was always an emulator in the loop. The software had never actually been tested fully in a closed loop scenario. And in fact, in the simulator, every time we activated the FGB looked like it was on fire, but it wasn't on fire. So that was our cue of, okay, if the smoke detectors go off, then we're worried, but if it just looks like it's on fire in the display, you're okay. We called this our 3 days of consecutive miracles. we could not believe that everything worked exactly according to plan. So finally, it was time to go in and ingress the vehicle. We had trained for almost 3 years, and about 3 months before our mission, they added a cosmonaut to our flight. He was supposed to be on the first expedition, and his flight kept getting delayed. The Russians thought it would be helpful to have him, and so we had the honor of flying with Currie-Gregg. Sergei is one of the most experienced cosmonauts, astronauts in the entire world, and he was fantastic. We had never discussed who goes through the hatch first. Is it the American commander? Is it the cosmonaut? And unbeknownst to us, they had talked and decided to go in side by side. So when they finally ingressed, this is in the US node, and the US node is a connecting piece, has 6 different ports on which additional station components were placed. When we finally made that call to the ground, Houston, this is the International Space Station. You know, that's sort of my moon mission for me, is what I tell the Apollo guys. It was really an honor to be there. Flying in space is all about teamwork. You see the picture of the commander hugging me after the flight, and what he's saying is, I can't believe we did this. We lived together, we trained together, we socialized together. There are no private offices in the astronaut office by design. If there's 7 people on a crew, you figure out a way to fit 7 desks in an office, and you become a cohesive element. And so that's the same way in the business world. It's the same way in the research world. You can achieve bold visions with a cohesive team, all pulling in the same direction, all with that grand mission. Because the only way to achieve something so bold is to go from this meager beginnings to finally the completed International Space Station, on which today the 53rd expedition crew is operating and has been continually operating since 1999. It wasn't an easy path. Along the way, we had the Columbia accident in 2003. We always said it took 3 people to operate the space station. We had to go down to a crew of 2. We also have a rule that says we never send people spacewalking unless somebody remains inside, for obvious reasons, in case there's an issue with the hatch. We violated all those rules because we had to. Because systems started to fail, and we had to send the guys out on extra behavior activity, and so you had to do what had to be done at the time. And so it's all about overcoming adversity, either in your personal life. When I flew my first flight, I was a single mom. That is not something I would have ever envisioned, and not something I would have said would be easy to be a young astronaut looking at your first flight as a single mom, but it happens. And so continually challenge yourself, continually challenge your teams, because this bold vision of having elements built literally all over the world and assembled 200 miles up in space, and then inhabited by multinational crews that we've worked together for almost 2 decades now, is just an incredible achievement. When I was a young military officer and going through ROTC and then Air Defense Artillery and then flight school, the Russians were our threat. And so here I was in 1998 standing in Red Square, flying with a Russian cosmonaut and working on this incredible project together. And it's through multinational cooperation, it's through everybody pulling together with this very bold vision that things as extraordinary as the International Space Station can occur. So thank you very much for allowing me to address you today. Congratulations to the distinguished alumni. My thanks to the invite from the department to address the students and the faculty and the alumni, and I wish you all the very best. Thank you.
It's not scripted, but I told Dr. Nancy Currie-Gregg that if we had some time for questions, that we could take some from the group. Does anybody have any questions? Jill.
The 2005 conference, I was present, Chair Nancy was my keynote speaker.
When you said Winter Stimulation Conference, I went, that sounds familiar.
Yeah, it was in 2005. I didn't realize you were talking about it. I would have brought you into that part of it.
The reason why I was asked to speak at that conference is because the Army was trying to transition a lot of their training to simulation. They were getting a lot of pushback. And Paul Kern was a 3-star general at the time in the Army, and what I told General Kern was, you know, the first time a shuttle pilot lands the shuttle is the first time he lands the shuttle. Every other time before then, he's operating in a simulator. Now, the shuttle training aircraft also operates in simulation mode, but we actually don't touch down. And so he thought that was a pretty compelling story to talk about, the use of simulation in human spaceflight, the use of VR. VR was so important for that task of mating those elements together. I was able to visualize what that looks like, even though it was only plus or minus 2 inches and 2 degrees, and even my crewmates were doubting my capability to learn that sight picture. I had a picture from the VR lab taped next to the television monitors in the shuttle, where I had the shuttle payload and cameras, and it was an identical match. When I came back from my first flight and I debriefed the robotic arm engineers at Johnson, I told them that the only difference between flying the arm in the simulator in Houston and on orbit was that incredible view out the window, that I could find no differences in terms of the flying characteristics of those arms.
Other questions from the group?
I have a question. What do you think about the privatization of space exploration versus government funding?
So, you know, I just left NASA at the end of September, and the NASA Engineering and Safety Center was started as a direct result of Columbia. Columbia Accident Investigation Board decided we needed an independent engineering organization with no ties to the program, so that if we saw an issue, we could look into it, we could do whatever tests, whatever analysis, build whatever models we needed to do, and we did not have to go back to the program manager and ask for that funding. And so we have been doing a lot of work with respect to our commercial space partners. Some of those partners have been flying very successfully in unmanned spacecraft, delivering supplies to and from the International Space Station. However, flying humans in space requires a lot greater reliability, and some of those partners have experienced some accidents along the way. And so we have learned the hard way. Through 3 accidents, the loss of 17 crew members, we have learned how harsh and unforgiving human spaceflight is. And so we are watching very intently over their shoulders. I think the country feels like it's time to leave low Earth orbit. My class patch in 1990 had the moon and Mars, because the first President Bush said, in 1989, declared we're going back to the moon and on to Mars. So we were picked in 1990 and we said, oh, we're the guys that get to go do that. And we still have not done that. And I really do believe in going back to the moon prior to going onto Mars, because the single limiting factor is not a technology factor, it's human physiology. And the understanding that we have of long-duration spaceflight on human physiology is still in development. We only have 1 crew member in our entire country that has flown in excess of 6 months. That was Scott Kelly. He flew a year-long mission just recently. It's called the Twin Study. His twin brother, Mark, was also an astronaut. He's married to Congresswoman Debbie Giffords. And so they used Mark as a ground control and then Scott as an on-orbit control. And we are seeing long-term medical effects from long-duration spaceflight. Until we fully understand the ramifications of those effects, we cannot send people on a mission to Mars. So it's very likely that we will go onto the moon. So is it the time to turn over low Earth orbit to their commercial partners? Perhaps, but where we have to have the diligence to maintain that same level of safety and reliability because our crew members will be getting on board. And I will tell you, as a person who worked in safety after the Columbia accident, it is a lot more difficult to tell a fellow crew member and his family, or her family, that that vehicle is safe and that your spouse or your mom or dad is going to come back home than it is to make the decision to take that risk yourself. So we owe it to those folks.
It's kind of a follow-up on you. I remember, it seems like one time we were talking, you were talking about the particle strikes in your vision in space and some of those things. Could you, elaborate a little bit on the human effect that that's different than when you're in space?
Yeah, so it's a great question, Bob. So the first thing that happens when you go to space is a fluid shift, and it happens almost immediately. And so you'll see a lot of crew members with very full faces, also results in a lot of congestion. And the body does not perceive that as fluid shift, it perceives it as fluid overload, so it starts to change some of your hormones, including ADH, antidiuretic hormone. Some of us, like me, are very adept at adjusting to that microgravity environment. But what we've learned is there's long-term effects. So one of them is called visual impairment intracranial pressure. And what we've seen is permanent visual acuity shifts in our long-duration crew members, up to 2 diopters, that does not recover. And so we see globe flattening, we see all kinds of structural changes in the eyes. And so we're saying, if the interocular pressure is that high, then what's the intracranial pressure? Which, of course, we're not taking any readings on right now. So there's a lot of research going on, because if it's increased intracranial pressure, then is there more propensity to develop long-term illnesses like Alzheimer's or so forth. So we owe it to crew members. Just recently, Congress passed a long-term astronaut health care act that they will now care for crew members if their illness is related to spaceflight, because we are seeing the effects of long-duration spaceflight on crew members. The retinal flashes, we're considered radiation workers. I flew on a Hubble Space Telescope mission. That was the highest. I went 350 miles, right through the South Atlantic anomaly, because we were at 28.5 degrees inclination. And so, especially when you try to go to sleep at night, you just see these retinal flashes. And as one of my crew members remarked, radiation is bad when you can see it. So we treat that very seriously, and we are tracked throughout our entire career as radiation work. There's also all kinds of issues with cardiovascular deconditioning. We've kind of gotten a handle on. Most crew members exercise an hour to 2 hours a day to mitigate those effects. Obviously, bone demineralization, bone density loss. But what we know, because a lot of astronauts are in their 40s, even 50s, is that bone that regenerates after a mission is not the same makeup as the bone that was lost during the mission. So still lots of research in the medical area to fully understand those effects.
What language did you speak on the International Space Station? And did you have any problems in communication?
So the language of the space station is English. However, in the Russian segments, they speak Russian to the Russian ground control. So pretty much the Russian elements are controlled by the Russian Space Agency. All the rest, including the Japanese, Canadian, Europeans, are controlled in Houston. And all of those international astronauts speak English. All astronauts get trained in Russian language. And I watched a Japanese crew member struggle as he was trying to take a course in Russian with an English professor, and he was trying to take the English and translate it into Japanese, and then translate it into Russian. And so I think he finally went and got his own Japanese instructor to teach him Russian, so he could cut out the middleman. But truly, English is the language, but most people are very conversant in Russian as well.
While you were in space, what did you miss the most, and what did you miss the least about
like he was gonna go like a block, maybe. Didn't miss traffic at all. And I was asked once by the press if I could have taken anything with me, what would I have taken with me? And I said my dog, just mostly to see my dog floating around the microgravity. I thought it was the coolest thing, because one of our experiments we flew rats, and watching the rats float around on day one and bump into each other and kind of look in their eye like, what's going on? They look just like their human counterparts in the show. So, you know, flying short duration missions, it's like a long camping trip. You know, you're all locked in, nobody can take a shower, nobody can get out, but it's a camping trip, and it's the greatest experience of your life. For long duration crew members, they actually do have a satellite phone, and so crew members call home all the time. One of the crew members, every time he floated by the phone, he used to call his wife. And I will say that I've heard the person that maybe felt the most remote was Frank Culbertson was on orbit when 9/11 happened. And he felt so helpless, but also was getting sort of that universal perspective of what was occurring. They could actually see the smoke from the World Trade Center from space. And he was, you know, and he just felt so detached that it was a struggle for him. He talks about that frequently.
Okay, please join me in thanking